What are the fundamental characteristics of the jumping and decomposition strategies for addition calculations? Let's see, first of all, the two strategies, both the jumping and the decomposition strategies, are actually decomposition strategies. We call them by different names because in the decomposition, the two numbers that are used, both in the addition and in the subtraction, are broken apart. While in the jumping strategy, the first one remains complete, let's say remains whole without splitting, and it is the second number that tells us how many jumps we have to go forwards or backwards, depending on whether it is subtraction or addition. So, even though only one is called decomposition, both are decomposition. Actually, we can say that decomposition breaks apart both numbers in parallel, while in jumping it is sequential. One is broken apart, then the other is based on that. Another characteristic that they have is that they are associated with various manipulative materials. We consider the decomposition strategies that are most related to the phase 10 material block. But it is also perfectly possible to do it with money, because what we need are materials that have a very strong decimal base. While for the jumping strategy, the associated manipulative materials are beaded necklaces, and from this manipulative material, what we are doing is seeking abstractions. Let's say, about which we have already spoken, that we go from the necklace to the bicolor line, from the bicolor line to a line with only one color, but with some demarcation, until we reach the empty number line. Therefore, one differentiating characteristic that the two strategies have is the supporting material they use, on which they're built. I think that in order to have the relationships clear of the similarities and differences that exist between the two strategies, it is better to use an example, and we can use a very simple one, such as 43 plus 25. Later, throughout the capsule, we will make things more complicated and look at other situations, but to characterize the two strategies, this type of example suits us perfectly. 43 plus 25. If I do it by decomposition, the idea is that 43 breaks apart as 40 plus 3 and 25 as 20 plus 5. The two numbers that are tens are grouped, and the two numbers that are units are grouped. And it is not necessary for the teacher to introduce it as one thing done like this. But rather using the material, the 43 could be represented by the students with 4 rods or bars and 3 cubes, and the 25 with 2 bars and 5 cubes. And therefore, when we propose that they gather them together, for them it is natural to gather the bars with bars and cubes with cubes. And therefore, doing 40 plus 20, which is 60, 3 plus 5, which is 8, and in total 68 comes naturally. On the other hand, if we think about the jumping strategy, the idea is that on the empty number line, at one place we say, here is the 43, and from here, we jump forward 25. Yes, moving forward because we are adding, and if not, then by moving backwards. But this 25, what does it mean? We can break it apart and do 2 jumps of 10 and 1 of 5, or 1 jump of 20 and 1 of 5. With the jump of 20 of the 43, we go to 63, and with the smaller jumps of 5, we arrive at 68. Obviously, both strategies lead us to the same outcome, let's say, but you could say the reasoning that there is behind each one of these is clearly defined by the materials that we have worked with, correct? And by the benefits of one and of the other that we keep talking about during the capsule. Why do we teach 2 different strategies for addition when we could use just one of them to respond to all the additions and subtractions raised at this stage? In mathematics, we are always interested in more than one solution, more than one way to deal with a problem. not just for addition and subtraction, or because we will do the same with multiplication and division. It's a way to act mathematically, to have different ways to address the types of problems. We need to understand that the jumping strategy and the decomposition strategy are two different ways to address an equation that can involve addition or subtraction. Okay? The fact is that we want students to use one or use the other according to which one is most convenient, which they can do if we have taught both. If we've taught just one, they would always have to tackle the problem in the same way. There is a very clear situation, which is sometimes when we set a mental addition like 48 plus 25, and we ask a child to do it, we can really see that they are imagining 48 with 25 underneath and working it out vertically when we ask them to do it mentally. That student shows us clearly that they're using a written calculation strategy to do a mental equation, and it's probably because they don't know that there are some strategies that are better for mental equations and others that are very good for written equations. The jumping strategy is a strategy that is especially good for mental calculation. Because if I have 48 plus 25, then what I do is think about 48. I don't have to break it down anymore. All I do is jump 25 forward. And so I jump from 48. If I jump 20, I get to 68, and here I have to jump 5. So to get to the 10, from 68, jump 2, and I get to 70, and I jump the 3 that I have left, and I am at 73. So it's a strategy that's especially suited to mental calculation, and that's why we teach the jumping strategy. Being especially good for mental calculation doesn't mean that it's not a good strategy for written calculation, and we allow that and we practice it, because one way to work on a mental calculation strategy is to practice it for written calculation as well. The decomposition strategy is a strategy that is especially adaptable to written calculations, and it's even the basis of algorithms, whether they are more personal algorithms or more standard algorithms like traditional algorithms. It also has a very clear application, not only with the physical materials that we have used mostly in the numbers techniques, which are base 10 blocks, but it is a type of strategy that its use becomes very evident in regard to money. When we have two amounts of money to put together, it makes sense to break down the numbers. Then we have advantages with both strategies. If we have the clear idea that for students to be flexible when they use a strategy, they have to know both so they can choose. If we don't teach competence in the two strategies, we are not really giving them the freedom to choose. But it's also important to understand that even though these two are the fundamental strategies, we don't apply them to addition calculations, jumping, and decomposition. We want students to develop other types of strategies, alternative strategies. We want them to be completely free if we ask them to do an addition like 99 plus 38 to work out 100 plus 38 and then take away 1. And when we say total freedom, what we mean by that is that when we provide context to practice addition and the addition in that situation is 99 plus 38, and we were hoping to see a vertical calculation, but the student uses this strategy of changing the addition, we shouldn't look at this as though it's cheating. On the contrary, they've made it easier, but they've applied genuine mathematical knowledge, because genuine mathematical knowledge is knowing that you can tackle a problem from a different perspective and are convinced that you will get the same solution in an easier way. And this kind of tendency, we can say, in which a student wants to make things easier, we have to use this as a tool to help them do mathematics more efficiently. And that's why we believe we should applaud students when they do something in a different way than what we have asked, but they did it in a way that is actually simpler. Should we make explicit connections between the two strategies in front of students? So far, we have emphasized that it is very important for a teacher to make connections, to analyze the weaknesses and strengths of each of the strategies, to analyze which is more convenient for one type of situation and which is more convenient for another, but we want to take it a step further. We want to make this comparison explicit in front of the students. So we find ourselves in the number lab. There are tasks where the student is explicitly asked to do the same addition both ways and to comment on what they observe, on the differences they see between the methods. We don't want students to think that one of the two strategies is easier or more difficult to do than the other, because it is not the strategy that makes the task easier, it's the numbers. If we have an addition that requires grouping cubes into tens with the vertical diagram, what historically we call addition or subtraction with carryover, when we analyze that same addition or that same subtraction using the jumping strategy, what we see is that it needs to jump in tens. While an addition that doesn't have carryover with jumping strategy is also easy because you don't have to jump in tens. So, the explicit comparison in front of the students is what allows me, as a teacher, to help them use one or the other according to criteria other than just their preference for one because they think it is easier. That is why we strongly encourage students to develop both strategies, so they are experts in both and will really be free to choose one or the other depending on the situation. Mental math or written calculation. Say if I want to do an addition, for example, where I add 199, it's much easier to jump 200 forward and then jump 1 back. In other words, the specific situations are what make us choose one strategy or the other, not the fact that one is better or that one is easier. Should we always give the student the freedom to choose the strategy that they use to solve an addition equation? The answer should almost always be to give them the freedom to choose. I mean, in the long run, we want to give total freedom. When we use a contextualized situation, we want to know whether or not the student connects it to what we do in class, the addition calculation to a real-life situation. We are not interested in which strategy they use. We are only interested in them adding or subtracting as appropriate, choosing the numbers that are involved in that equation correctly, and translating the result into a response that is consistent with what we have asked them. So in a contextualized situation, I have no doubt that we should give them freedom. But the fundamental issue here is that sometimes, for educational purposes, we have to restrict this right to choose. What do I mean by that? In order to give students the freedom to choose, we have to make sure that they master all the strategies. And that's why we need to spend some time practicing the decomposition strategy and some time practicing the jumping strategy. And there should also be time spent on practicing alternative strategies where it is compulsory to use a strategy other than jumping or decomposition. Sometimes we give them tasks and we specify which strategy to use, but we want them to change that for another one to get the same result, but not just any other one that makes it easier. If we don't teach specifically, there will be students who don't develop these skills and therefore will not have them within their reach. They will not have the same tools as their classmates and won't be flexible in their decisions. Obviously, we could solve all the addition problems in the 1 to 100 range that we ask students to do with a single strategy. But we want more than that. It is true that this is a very important goal, but if we only focus on the goals of lower primary, of early primary education, that might be enough for this stage, but we're already thinking about what's next. And what's next is that learning addition and subtraction will be part of what's involved in multiplication and division. So, bearing in mind what comes later, we need students to have more than one strategy. And that's why there are certain moments in which we establish a teaching challenge that limits students to doing these calculations and limits them to using a certain strategy. But I'll say it again, just to reiterate, our ultimate objective is to give students total freedom so that when they have to do an addition, they can choose the strategy they use to solve it on their own.